Hello again, this is Behrooz Kavehie with the new series of Advanced R Programming. In my previous videos, I covered SPSS and its uses. In this series, I will be teaching you how to use programming commands like while, for, if, and array functions in the R programming language environment. We are going to use these functions and commands in a statistical sampling technique. The sampling method I have chosen for today's video is simple random sampling or SRS. The main goal of this video is to teach you how to develop an R program with the aim to extract samples from a hypothetical normal distribution. The sub-goals are to teach you how to develop a program using the following commands: for, while, if, and also arrays. For those of you who might not be familiar with term array, it is a number of variables which either have the same name, are of the same time, are stored next to each other, and are distinguished via an index. Note that the programming method presented in this course is not necessarily the best programming method for sampling, and the purpose of this tutorial is to master programming using conditional statements and loops, as well as using arrays in R programming language. So, what's the main goal? Since we don't have a real data, in step 1, we use a random number generator to select about 500 members for our population. I will explain what a population is in the next slides. In step 2, we will extract samples from the population using statistical methods. Step 3 is to calculate the mean and the variance of the sample. Sample mean and sample variance are actually estimating of our population actual mean and variance. We are going to test the accuracy of the simple random sampling method. Moving on to our population. Let's assume that our statistical population is a compilation of people's weight and has a normal distribution. Also, our population consists of 500 people. In this case, our measured attribute of interest is people's weight. In this tutorial, I have used 3 colors in order for you to easily differentiate between program sources. Let's go through the color coding I have used. The color red is used to indicate reserved words and operators of R. Take a look at the examples. The color black is used to indicate user-defined variables, meaning the names and data I myself have defined in the process. I have provided 2 examples. Let me break it down. Age is a variable I have defined, hence it is written in black. Equal. Equal is a reserved operator, hence it is red. 19 is a data I have defined, and it is black. The same goes for the other example. Candidate name and the data are both user-defined and written in black. The reserved word equal and double quote are again written in red. The color blue is used for R standard functions, which are also called built-in functions. Take a look at the examples. The user-defined variable AB is in black. The trunc function has been used a lot in this video. What it does is that it removes the decimal part of the numbers. Keep in mind that this is not like the round function. The round function, as the name implies, rounds the number up or down, but the trunc function eliminates the decimal part. Moving on to sampling. Our method of sampling is the simple random sampling method, or SRS. It is a probability sampling method, which is one of the easiest and precise method of sampling. We choose this method according to the features of our population. Given the population is uniform, we can use SRS. Sample size. We choose our 217 samples with the Cochrane formula or the Kavehie and Morgan table to estimate the ratios. In order to be able to make estimation on a population of 500, we are going to need around 217 samples. What is our goal? We are seeking to estimate the mean, variance, and the standard deviation of the weight of the mentioned population. Would it be possible for us to develop a program that through some calculation could give us a picture of what is going on in the actual population? If you recall, I mentioned that there are 3 steps: generate a population, extract samples, and eventually a calculation. We are going to start with step 1. We have to generate a normal population. In order for you to better grasp the topic, I will try to explain these steps in a more structured programming style. The IDE we are currently using is RStudio, but since all the commands we are going to use here are standard and you are not limited to RStudio, our population size is supposed to be 500. All we need is the array command. Arrays, as I mentioned earlier, was a number of variables which either have the same name, are of the same type, and are stored next to each other and are distinguished via an index. I am going to name the array population data, which is going to be the weight population. I am going to define it using the following commands. Keep in mind that R is case sensitive and we use a capital N. Array is in blue since it is a built-in R function. 0 and N are in black because I have defined them. And red is used for the operators. We have the array name. The initial values of the array are 0 and it is going to have n number of elements inside of it. So I have 500 samples with the value of 0. Now if I run population data by just writing the name of the array and pressing enter, we should see the following results. This is the result of the comment. It has started from row 1 and ended with 52, continued to 53 and ended with 500. It has created an array with the name population data, which contains 500 zeros. Now we have our population, but we don't have actual data inside of it. We were supposed to fill this array with a normal distribution of weights. Now suppose the weight of people in this population is said to have a mean of 75 kilograms and a standard deviation of 3.25 kilograms. These are the attributes of the population I am going to sample from. But before that, I need to generate my population. I need 500 samples that have a mean of 75 kilograms and a standard deviation of 3.25 kilograms. In the previous slide, we defined 0 to be the value of population data. Now we have 500 elements cells. This is going to be written after the previous comment. for I that starts from 1 and ends by n, what I am doing here is that I am defining an endless loop that repeats itself 500 times. It is going to first place 1, then 2, and when it reaches n plus 1, it stops and carries on to the next comment. Alright, it starts with population data of an I of 1. This section needs a little explanation. Normally, we would use a random normal function which has specific features. This function requires 3 inputs. The first one is the number of data we want from it, since our input only has one assigned space from all 500 rows. The first argument is 1. The number of random numbers that are going to be generated. The second one assigns the mean, which is whatever we want it to be. I'm going to write 75. The last one is the standard deviation again, provided in the example 3.25. At this point, the function is going to generate a random number for us. The issue here is that the generated number has infinite numbers in its decimal section, which are of no use in this example. The thing is that if you ever ask anyone their weight, they will either tell you that it's 75, or if they want to be more precise, they will say it's 75.215. Hence, the number is not going to have more than 3 decimals. 2 decimal digits would suffice, but 3 is also good, since we could easily convert 1000 grams to kilogram. That's why we have multiplied by 1000. In this way, the decimal point moves 3 digits to the right, and then the trunc function removes the fractional part of at the end of the number is divided by 1000 to give us that 3 decimal digits. The output is a number which consists of a double or triple digit integer part and a 3-digit decimal part and a decimal point. So here we had an array called population data, an assignment argument that puts the value on the right in the variable on the left. Trunc, which we already discussed, keep the integer part of the value. Our norm function, which was the random number generator, and finally we run the command. These 500 numbers have now replaced the 500 zeros in population data. Now we have a statistical population that contains 500 numbers with a maximum of 3 decimal digits, normally distributed, with a mean of 75 and a standard deviation of 3.25. We are done with the population. Now we move on to the next step, which is our more technical step, sampling. We are supposed to extract a sample from our population. First, we have to state how many samples we need. We define an small n of 270 samples. Please pay attention to the lowercase n. In statistics, we use a capital N to indicate our population and a small n to indicate sample size. The R environment, being case sensitive, allows us to make this distinction. The sample size is 270. As previously done, I defined a new array called selector index. What is selector index? It is an array which contains 500 zeros, and further I give the instructions as to what variable must be put in it. My goal is to have 500 zeros and ones. These zeros and ones are randomly distributed in the array, and there are a total of 217 ones in the population. Now, how can these ones be randomly distributed? The program is going to do the following commands for an I starting from 1 to 270. Here I have used the random uniform function. This function is going to give me a random number from the uniform distribution. The previous similar function gave us a number from the normal distribution. This is going to give me a single random number from 0 to n. I have corrected this in the upcoming slides and changed this 0 to 1. What it's going to do is that, for example, if the generated number is 35, the 0 in 35th cell in our selector index is going to be replaced with 1. The next generated number might be 420 or even 2. The same thing is going to happen to them. As it finishes, I am going to have 270 ones which will be placed in the array. How? This loop is going to repeat itself 500 times. It first generates a number. The number will be our index. This trunc function is just here for you to know that we can also use trunc with this function. Then we use the selector index of index and replace it with 1. Take a moment to reflect on what's going on here. I didn't give it a specific cell number. If it generated 35, it should replace the 35th cell with 1. If it generated 400, it should replace the 400th cell with 1. I have played a trick for the program to easily replace the set index with 1. I finally commanded it to show me the array. Here you can see the output. There is an array of 500 elements which contains zeros and ones, 217 of which are ones and the rest are zero. Each one of these numbers shown here indicate whether or not you choose the number or not. Take this one for complete. It will indicate whether or not we choose this cell. If it's a 1, we choose it. If it's a 0, we won't. But pay close attention to this section. A serious issue lies in this code. The numbers generated by this code are not unique, meaning any one number can be generated multiple times. It could generate 1 7 times. The randomness is equally probable. It could generate 1 7 times. The randomness is equally probable. So the issue of not reaching our population of n exists. It might collect 117 instead of 270. In conclusion, this code is flawed. Let's try and fix it. How are we going to overcome this issue? We are going to make some changes to our code. Look here. I defined a new array called duplicate array, and it is going to store the selected elements in it. It is going to start from 0 to n, a small n, which is 217. Duplicate index is the index which is going to manage the above array. Very well. We have this command in our previous code, and it is going to start from 0 to capital N, which was 500. In the previous code, we used the if command, but here we are going to go with while. As long as while is true. What I did here is that I created an endless loop. Now, when is the program going to exit the loop? This is why we needed to define I. Whenever the I is acceptable, I will add it by 1 and carry on with the loop. But when I reaches N, the program is going to exit the loop. Now, from the top, let me explain in detail. We defined an endless loop, and it is going to generate a random number using the runif function. As you can see, I replaced the 0 to 1 here. Okay, so it is going to generate one random number between 1 and n, capital N, and truncate it and put it in selector index. Next, found flag is going to be false, which means that if it doesn't find a number, it is going to turn the flag to false, meaning nothing is found. Now it is going to do this for an m starting from 1 to n with the value of 217. We have a duplicate value here that I am going to start with its first value. I want to see if its first value is equal to the found index or not. Here is an example. Between 1 and 500, the number 7 has been generated by runif function. The program is going to check the first cell of the duplicate array to see if it is equal to m, which is 1. It is not. So the if command stops and it is going to restart from the top of the loop. The value of m is now 2. Is it equal to 7? No. Again from the top. Next is 3. Is it equal to 7? Yes. We have already found 7 and placed it in the third cell. We should no longer use 7, and found flag is going to change into true. 4 is going to break and we are going to exit the loop. Is the found flag equal to false, meaning you haven't found anything? It is not. Found flag is true, so you cannot continue with this command and it should exit if. Why? Because a cell found, so you should leave it. Is I equal to n? No. We didn't make any changes to I at any stage of this code up until now, or it has not reached 217. We won't exit the loop exactly because we haven't reached an I of 217. We reach the end of the loop and start from the loop. While is still true, so again we start by generating a new random number with the flag still false. So it's going to skip this block and reach the false found flag. Now that our found flag is false, this part that used to be 0 is now going to be added by 1, and the digits cell number in the duplicate array is going to be kept. Take 7 for example. If 7 is recorded, it will no longer pop up. In the meantime, change the 7th index of the sector index we have in the previous slide to 1. We know now that the 7th index is going to be chosen, but we will not allow it to reoccur. We add I by 1. which means I have found a random number. Is I equal to 217? No. We go back up and generate a new number. Again and again. This process will repeat itself 1000 times until it finds 270 numbers. And when it does, it breaks the loop. Now, if you look closely here, you will see that in the first method, only 178 numbers were found, as though in the second method 270 numbers were found. So the threat of not reaching the intended number for our population is eradicated. It might seem a bit complicated, but I assure you, you will get a hang on it when you do it yourself. Take a look here. Here we have an indicator array which consists of zeros and ones that indicate the selection of a certain value. These blue arrays indicate that a certain value has not been selected. This 0 shows that 70.103 in our main population was not selected. Again, this 0 indicates that 79.398 is also not in our selected sample. These two arrays are corresponding, meaning there are 500 numbers in both. Here I have only shown a part of the second array. The red arrows on the other hand indicate the values that have been chosen. For example, this one right here indicates that 72.305 is indeed in our chosen samples. This other one here indicates that 72.533 is also one of our chosen samples. There are 500 numbers here. 270 of which are ones, and these ones are direct indicators of our main population values. Now we understand the scenario. We have an array of ones and zeros that tell us exactly which value of the main population we are supposed to choose from. Hence, we should separate the values that have an index of 1. Now to the rest of the program. Sample data is my final data, and I am going to store my samples in here, which needs enough space for n elements. This array here is very important in our program. What we have here is an array of 217 zeros, which are going to be replaced with our chosen samples. I brought this here so you could see it. I've been defined a j with the value of 0. For I that starts with 1 and ends with capital N, so it is going to do this 500 times because I want it to scan all 500 of the elements in my population. If the selector index of I is equal to 1, the program is going to fill the sample data with the concurrent element of population data. You might ask why I have chosen J for this index and I for this one. Since they have different number of elements, I is going to go from 1 to 500 and J is going to go from 1 to 217. Hence, these two should have different names. Sample data consists of 217 elements and population data consists of 500. In order to prevent any issue, I have given J a value of 0, and each time it finds a 1, it will be added by 1, and that will be my second array's index. Now it's going to show me sample data. This is your selected sample. This picture here is different from the other picture because I ran the program multiple times, and as we already know, each time random numbers are going to be generated. So from 500 numbers I have 217. We choose our samples from our population and place them in our samples array, and this was the result. Congratulations! You have extracted a scientific sample from your statistical population. Now that we are done with sampling, we are going to move on to the third step, which was calculations. As for our calculations, we are supposed to calculate the mean, variance, and standard deviation of our sample. This is the formula for calculating the mean. Sigma of I that starts with 1 and ends with a small n for xi. Alright, some data is equal to 0. Now, why is that? Because 0 is a neutral number. It doesn't matter if you add to or subtract it from any number. The output will be unaffected by it. That's why we use it for our summation. Now, for from 1 to a small n, which is 217. Some data is going to be the summation of some data and sample data of I. It will find the first sample, add it to 0 and store it in some data. For an I of 2, it will add the second sample to the previous one and again store it in some data. What I have here is a cumulative summation. When I reach 217 as my small n, all of the data in sample data will be summed. Sum right here is exactly the sigma part of the mean formula. As for my sample average, it will be calculated by dividing some data by small n. All I have to do now is to run the program and use the sprintf command, which is used in files and is actually a very useful command to show my formatted result. Let's go through the command. In parentheses, write average or sample mean. This phrase is going to be shown as our output. And show me the sample average in front of it. By running this command, we will see the phrase and a number in front of it. With this format, I have commanded it to show me a number with six integer digits and 2 decimal digits. Pay attention to the empty space here. Now that we have our sample mean, we will move on to calculating variance. It's a bit more complicated than mean, but let me explain. This right here is the formula of variance. Dividing by n minus 1 is for avoiding bias. The standard deviation is the square root of the variance, which is basically this formula right here. We have the value of sample average, the mean through our previous calculations. Now here I have defined some data too. It is basically the same as some data. If you look closely here, you should be able to distinguish different parts of the mathematical formula in the code I have written here. For example, the power function creates the power of 2. Look carefully to the code. As seen before, this is how we calculate sigma in our program using the for command in this order. This is exactly what we did to calculate our mean. And finally, the result of those calculations to the power of 2 is divided by n minus 1. The sample variance is then the summation of the subtraction to the power of 2 divided by n minus 1, due to the fact that we want to prevent bias. But note that if your sample size is large enough, you could just go ahead and divide it by n. So how should we calculate a standard deviation? We just need to calculate the square root of the variance with the built-in sqrt function. This function will easily calculate the standard deviation for me and store in it SD. We use the sprintf function again to print our results. This time I want it to show both variance and standard deviation at the same time. As before, I need a phrase, a format in quotation marks, again a phrase and a format in quotation marks. At the end, the value of sample, variance, and SD are going to be shown where the F and F are. Take a look at the output. Sample variance is equal to 9.37 and the standard deviation is equal to 3.12. Do you recall earlier? Let's take a look at our population. I said that I want a randomly generated population with the mean of 75 and an SD a 3.12. Now keep in mind we programmed this code hypothetically and that we do not know this value and we are doing all this to try and calculate them. Let's go back to where we were. We wanted a mean of 75 and a standard deviation of 3.25. What has our program calculated for us? The mean is calculated as 75.99, which is pretty close to our intended number, with the confidence level of 95%. The SD is 3.12, which is again optimal and desirable. So, without even having the original population at hand and using only 270 samples of the population, we were able to estimate the mean, variance, and standard deviation of our population easily. You can see our entire program in this slide from start to the finish. If you feel like you need the whole program, you can just pause and take a good look at what I did here. Keep in mind that the sole purpose of this video was teach you how to use for, if, while, functions, and arrays. If not, we could have easily used the built-in function of R in order to calculate mean, variance, and standard deviation. If ever you needed to calculate these three, you can just go ahead and use the commands below. Just a final note. If you pay attention to the variance function, you will see that it requires two arguments. The first one is your array, and the second one asks you whether or not you want to calculate it with the unbiased or not. If the unbiased is true, your summations will be divided by n-1. And if unbiased is false, your summation will be divided by small n. Finally, you can see an example of the built-in functions of R. With these 5 lines of code, you can do all the things I told you. Compare these 5 lines with the programming codes that I presented. Thank you for staying this far. I really hope you enjoyed this episode and learned something new. Don't forget to give me feedback on this video or if you would like me to teach you another topic. Good luck and goodbye. Thank you.